Eric Darling here with Darling Data, and we are back to talking about stored procedures in SQL Server. And in this video, we're going to talk a bit about batching modifications because there are some things that come along with batching that not a lot of people think about as they get along in their process of stuff, right? And there are some important things to consider depending on what kind of batch modification you're doing, and also like how you need to handle various, like tying back into the last video about server procedure with the error handling stuff, sort of figuring out like, okay, well, like what's going to happen if under these circumstances, like if I hit an error, if like something weird happens, like what do I do? So we're going to talk a bit about that. If you like this channel and the content that I produce and you think, wow, Eric Darling is worth $4 a month, there's a link down in the video description where you can become a member of this fine channel and do that. But don't let $4 a month be like the limit. You can go higher than that if you want. Like I'm not gonna complain. If you want to, like, instead of buying me like some of one espresso, you want to buy me some of two espressos, that'd be cool too. If you're more of a tea person and you just don't want your money going towards the evil coffee bean, you can do all sorts of other things to support the channel. You can like, you can comment, you can subscribe, and if you want to ask questions that I will answer publicly in my office hours videos, you can do that via that link, which is also a link down there to make it real easy for clicking. If you need consulting help with SQL Server, if you are having performance problems and you think it's high time you hired someone to come look at these things, well, guess what? My rates are reasonable. I do all this stuff, and I'm great at it. Thanks for watching. If you want some SQL Server training, I have that too. Also at a reasonable rate, about $150 per month once you apply their discount code. And I don't know, you sit and you watch it and you learn and you get better at stuff. But you actually have to watch it for that to happen. It just does not happen through osmosis. You cannot just headbutt the screen and receive information. SQL Saturday, New York City, 2025 is happening May the 10th with a pre-con on May the 9th, a performance tuning pre-con by Andreas Walter, and we will have a great time on both of those days. I will be at both, serving you lunch. I'm going to be dressed up like an old school lunch lady, hairnet, apron, rubber, those weird baggy gloves. I got the works. It's going to be fun. Anyway, let's talk a little bit about batching modifications. So the goal of batching modification is to accomplish a large number of row modifications without like causing a big issue on the server. Like if you have a very, very large amount of data that needs to change in a database, batching modifications is a great way to lessen the impact by separating it into smaller batches of changes. Like from the perspective of, like locking and blocking the transaction log, and like hitting physical problems with the server, like your log file fills up and like you hit an error and the whole thing rolls back. Like hitting an error in one batch is a whole lot less devastating than hitting an error when you're like 99% of the way through a really big modification. There's just a lot of stuff that there's a lot of stuff that batching modifications can help. One thing that it may not help is the overall time it takes to get that amount of work done, because you still have to do that full unit of work, right? Like let's say you have to do something to like 10 million, 20 million rows, and doing it all in one chunk would take an hour. Batching up the modifications, it might still take an hour, but the point is during that hour, you're just biting off smaller chunks rather than trying to do the whole thing at once, right? That's the goal of batching the modifications. Probably obviously like the canonical post for me about batching modifications is Michael J. Swart, originally published back in 2014. I still reference it whenever I need to start something, just to make sure that I'm like mentally I'm just like in the right place for it. You might have some other requirements as well. A while back, I wrote this post called "Batching Modification Queries is Great Until," and this is about updates. So I do want to walk over to that code for a second, because there is some stuff in here that does bear repeating. So like if you wanted to write code in a way where like if you're like inserting data into a table from like something else, like batching inserts, fine. Like like you don't have to worry about too much, because you have the source data over here, right? Like you're just pulling data from here over here, and then when you're done with that whole thing, like if all your data is there and safe and sound, you can truncate this if you want. You can also keep it for reference. I don't know. I don't care. If you're deleting data and you're just like, this is stuff that we no longer care about, or this is stuff that we legally have to get rid of and we can't keep it around anymore. Well, I mean, again, like if a batch errors out for some reason and you move on to the next batch, you just have to figure out at some point, like, okay, what went wrong there? But if you're updating data and either something goes wrong, or you're in a situation where like, okay, look, I have to update these 1,000,000 rows. I'm going to do it 1,000 rows at a time. But if any one of these batches errors out, I have to change this data back to the way it was before. I can't keep going. I like there is a problem with like the data somehow that I need to keep going. Like one handy way of dealing with that would be to like do an update with the output clause and output the data that changed into another table, so that you can roll back that stuff. Because if you're doing all these batch modifications, you don't want to do it all within the scope of one transaction, because then you have most of the same problems that you would have if you were trying to do stuff in just one big update anyway. And if you do it in like smaller transactions where you're like, you could either like do a transaction for every update, or we're going to talk later about the concept of like batching batches kind of for like with transactions. Like once you commit that's done, and you can't roll that back. Like you're on to the next transaction once that starts. So like for some stuff, you may have to preserve the data as it was before you made the changes for updates in order to roll that stuff back to something else. So the update stuff is very useful, or rather doing the update with the output to capture that data can be a pretty useful thing in those cases. Those are pretty rare though. Like those aren't things that I run into very often, right? So well, there's two things about that. One, it's not a requirement that I run into very often. Most people are just like, well, if one batch hit a problem, we can just figure out what went wrong with that batch. We don't need to roll back like, the 90 million rows we just changed because, there was a problem with row 10 million, right? It's not a very common requirement. But if it is, there are ways to preserve the previous data and then like batch back through and like undo all the work you did. It's a pain, but there are ways to do it. It would be nice if it would be nice if SQL Server had something like Oracle has with like the flashback tables. The temporal table SQL Server has probably wouldn't be the greatest thing for this, but you could use that too. Temporal tables just have too many problems for me to like recommend them as a great source of truth for stuff. So one thing, or rather a couple of things that are worth talking about in here are, like how you find where you want to start. Typically you want to use a primary key column because that's going to get you, it's not nullable, which is great. And B, it's since it's a primary key, it's indexed, and it's very easy for you to sort of like page through a primary key where you're like filtering on, say, like where the primary key is greater than this and then order by the primary key. It just makes life a lot easier. If you don't have a primary key on a table, you're stuck with some weird cursor options, right? There's some very strange ways to page through unordered data with a cursor. We're not going to talk about that here though, because that's a little bit too exotic for general consumption. But there are two ways to do it, right? You could either, just declare some parameters, or you declare some variables, or use some parameterized stuff, and you can find stuff in like the table that you want, the rows in the table you want to affect in one batch, and then go through here in another. Another way you could do this, so actually one thing that it was worth talking about here is whenever I need to do something like this, I like to set up like sort of an external control table, because what happens is, if like, let's say this batch runs for some amount of time, right? You could build a timer into this where you're like, if this has been running for 6 hours, it needs to stop, right? Like, like even like Ola Hallingren scripts have like stoppers in them. Like this job is only allowed, like after the job is run for this long, we're like, don't process any more commands. So you could totally do something like that here, and you could totally do something like that with a control table. One thing that I like to do is has to have an external control table, and I like to capture some information about what's going on in there. So like if I have multiple jobs that have to do something like this, I'll put in the job name, the name of the loop that I'm currently in, if there are multiple like steps to it, if the name of the step that I'm in, if it's the current step that's executing, or if it's just like the next thing, the last completion time, and usually a computed column where I'll have like the start time and the completion time like set like computed out with date diff to like minutes or hours or seconds or something, so that I can very easily sort of like gauge how, like if I need to fix anything in any of these loops, right? Like how long does this take? Wow, there's something's terrible in there. Maybe we need an index or something. But I like to have at minimum a table that helps me control if the loop should keep going, because inevitably what happens is like if you don't have anything built in to stop it, like eventually you're going to be like, okay, well, I'm going to do something, and this has been running for a long time. It's getting into the business. I'm just going to hit cancel. Like if you're in the middle of this, like it's kind of annoying. Like you want this thing to be able to finish. So what I like to do is set up sort of a loop, what I call a loop controller table, and I'll just say, like, should I continue? Yes. And then in the loop, I'll say, while the row count is greater than 0, in other words, while I still have rows to process, and like I'm allowed to continue, I want to keep running this loop. So that way, if I decide that like this thing has been running too long, I can just update the loop controller table to false, and then the loop will stop the next time before it starts another batch of modification. So I can at least finish the last thing that I'm doing cleanly before bailing out. So like, and again, if you have a loop controller table with like, job name, step name, stuff like that, and it like you would have to just tailor your where clause to make sure you're ending the loop for the specific thing that you care about stopping. Another interesting question that comes up with these sorts of batch modifications is around isolation levels. Again, this is not a terribly common requirement, but it is worth noting that no matter which way you do this, you are subject to potential concurrency issues. So if you care about that, you need to think about like A, like transactions, and B, locking hints for when you find data. So there's essentially two ways of looking for it, but both of them are subject to concurrency problems potentially. Like not always, and you might not care about them, but if you're not okay with them, you do have to think about that. Is like, let's say like you're using read committed, right? The crappy isolation level. If you're unfamiliar with why I think read committed is a crappy isolation level, I highly suggest you watch my series, Everything You Know About Isolation Levels is Wrong. Very good stuff in there, all about problems with read committed. But generally, like let's say you do something here and you find this data, and then something happens here in another transaction which alters like whatever like the correctness of the data that you found here, like maybe invalidates something that you found in here. Like let's say there was some additional where clause where like you're saying where the largest key processed is greater than or equal to the last thing that I just did, and the last modification date is like older than it, like a week or a month or a year or something. And then something happens that like changes that last modification date, and all of a sudden you would be doing something to a row that you shouldn't be doing something to anymore. that could be a problem, right? Like all of a sudden, you shouldn't be doing something with this, right? And that could happen if you did the update like this too, because in this scope, you would take a lock here, but in this scope, you would not have any locks taken that would prevent data from being read or prevent data from moving around data you've already read. So something could happen, like even with like a subquery thing like this, where you would invalidate the stuff that you would be working on in the update. So you do have to be careful. So in those cases, like depending on what you care about and what you need to happen, you could either add in locking hints. You could use a static cursor, which copies the table data that you're going to be working on. If you don't want that to happen, you could use a dynamic cursor where it would be working directly off the table data. Or if you like, a key set cursor would also technically preserve the key values, but not any other table data. So the static cursor might be the best way to go there, depending on what you want. But you might have, if you do care about isolating the work that the batch is doing and not allowing any other queries to mess with that data while you're in the process of like either finding it or modifying it, you might have to use use a transaction, and you might have to add in that should have been upd lock, not hold lock. Hold lock is a synonym for serializable, which means I probably messed that up somewhere else too. But anyway, so you would have to, because like, actually this came up in the YouTube comments recently. One thing that I like about some other database platforms like Postgres, MySQL, I think even Oracle has it, is the select for update clause. So like, instead of having to be surprised by locking hints in your from clause, you could do something like when you write the query, you say like select for update up here, and then it turns that select into a locking select. So you could do that here, like take locks on the rows that you find in this batch, and then like pass that in here. But again, you would need this down here as well if you want it. Like, so like if you're finding the next batch max using a select before you do the update, you would have to put that in there. And then if you are finding the 1,000 rows in a where clause, you could do that down here, but you would need the locking hint if you care about like nothing else, like messing with that data as you make your way through. Like kind of going back to some of the stuff that we talked about before in the previous video about like error and situation handling, writing batches like this is a great place to have retry logic built in, because there are going to be times when your batch gets either deadlocked or blocked, and you don't want to like keep trying to, or like cause a bigger blocking chain than might already exist. You like just want things to kind of keep going and make progress. Depending on the batch, or depending on the purpose of the batch, you might not care to the point where you could put like a read past hint in your query as a locking hint, so that you skip over any rows that are locked. But that's more like a queue table situation. What we're talking about here is where you like a situation where, like, let's say you kept hitting deadlocks when you try to do your modification, or let's say that if you don't want your process colliding with anything else, you might stick like a lock timeout, or like retry logic if you hit a deadlock. And this comes back to like how you would incorporate some of the retry stuff that I talked about in the last video with a batching process, so that you could very easily like if you hit a problem within your loop, you just go back and start your loop over. Like you just retry that batch the next time around. So that would be one way of doing it. So yeah, anyway, there's a lot of interesting stuff to think about when it comes to batching modifications. Is this something that I can batch? Is this something that like it's even allowable to split this up into chunks? There are some situations where it's not. The best way to write the batch, again, that Michael J. Swart blog post is probably my favorite. Like, it's a great starting point for things. It's a great explanation of things. There's a lot of good technical detail in there. If it's an update loop and you need to like maybe roll that stuff back, then that would be one thing. I guess that could go for deletes too, but that depends on how much you care about the data. And then of course, like all sorts of other concurrency stuff like should be at least on your mind when you're writing this stuff. You might decide immediately that you don't care, but at least have the mental conversation with yourself about how much protection your batching process needs, and always give yourself a way to bail out of the loop. So have that external control table or like a job logging table where you can control exactly like how long a loop can run for, or if you want to bail out on the next loop through, because that gives you a lot of flexibility for controlling the loop that's not just hitting cancel in the middle of it and wondering when things will finish. So thank you for watching. I hope you enjoyed yourselves. I hope you learned something, and I will see you in the next video where, well, I haven't quite organized the schedule yet, so the next video might be a surprise. We'll see how it goes. Anyway, thank you for watching.